All right, so the first thing that we have to do if we're trying to find the probability of Greg and Olga passing factor 8 deficiency onto their children is setting up a key for the symbols to show the different alleles. So you see that I'm making a regular X be the unaffected allele. An X with a mark in the lower right is for the affected allele that leads to factor 8 deficiency. And then we'll just use a normal Y to designate the Y that males inherit. The next thing that we have to do is find Greg and Olga's genotypes. So we'll start with Greg because he's easier than Olga. We know that Greg is a normal X and a normal Y because he is unaffected by factor 8 deficiency. And because factor 8 deficiency is a sex-linked recessive disorder, males cannot be carriers. So since he's unaffected, we know he does not have the allele. All right, now let's talk about Olga, who's a little bit more complicated. We know that her mother was a carrier for factor 8 deficiency because we know her brother has factor 8 deficiency, and men always inherit sex-linked recessive disorders from their mother. So what that means is that Olga can either be a carrier for the factor 8 deficiency allele, or she can be homozygous dominant and not carry the allele. In order for us to find the probability of those two cases, we have to do a Punnett square. We know Olga's mother's genotype is heterozygous because, like we said before, she passed the factor 8 deficiency allele to her son. We also know that Olga's father has an unaffected X because he is unaffected by factor 8 deficiency. So I'm going to do this Punnett square quickly just to show all the possible outcomes. We only need to look at the females in the Punnett square to determine if Olga is a carrier because Olga is female. So if we look at the female, the two boxes that are female of the four, we see that there's a 50% chance that Olga is a carrier. All right, now that we know the probability of Olga being a carrier, we have to calculate the probability of her passing that allele on to her children if she is a carrier and if she's not a carrier. So first, in blue here on the left, I'm going to show a Punnett square for the case in which Olga is not a carrier. And I'm going to just write Greg and Olga's genotypes prior to writing out the Punnett square. So you see that they both have, Olga is homozygous for the unaffected X's, and Greg has a normal X and a normal Y. So in the case in which Olga is not a carrier, there's a 0% chance that she will pass the allele on to her offspring, and therefore a 0% chance of her offspring having factor 8 deficiency. Now let's consider the case in which Olga is a carrier. I'm just going to do the Punnett square quickly here. So you can see by my yellow highlighting that there's a 50% chance that Olga will pass on her allele for factor 8 deficiency to her offspring. But there's only a 25% chance, as I've highlighted in pink, that she will have an affected child, and that child would be a male. All right, so now we have to calculate the total probability of Greg and Olga having an affected child. And because these probabilities are independent events, we're going to multiply them. So first, we have the 50% chance that Olga is a carrier, and we're going to multiply that by the 25% chance of her having an affected child if she is a carrier. And what that's going to give us is a total of a 12.5% chance that Greg and Olga will have an affected child. Now let's calculate the chance that Olga passes the allele onto her children, both unaffected and carrier children. So we're going to multiply the 50% chance that Olga is a carrier by the 50% chance that she passes the allele to her children. And that is going to give us a 25% chance that Olga and Greg pass the allele to their children. So now you know Olga and Greg have a 25% chance of passing the factor 8 deficiency allele onto their children and a 12.5% chance of having an affected child.